My name is Bob Goldsand. I'm a staff partner architect at VMware, and I'll be co-presenting with my colleague, Todd Muirhead.
Yeah, Todd Muirhead. I'm a member of the VMware Performance Engineering team. I've been with VMware for about 8 years and focus on database performance for the most part, other things sometimes.
So we're going to be talking about Extreme Performance Series, part of the Extreme Performance Series, about optimizing your mission and business critical workloads using NSX and vRealize Network Insight. We'll start off with the disclaimer. So I think everybody has seen this by now, hopefully. He's nodding his head, so I'm going to move on. So for the agenda, we're going to briefly talk about NSX, give an overview of NSX, what it is, what it does, how it's related to application and database performance, and then we're going to talk about the elimination of network hairpinning within NSX, and it's well known to network engineers, but not really at the application tier, and that's what we're going to talk about today, how it matters. Then we're going to present, Todd's going to present the results that we've gotten from the elimination of network hairpinning. And then we'll talk about VRNI, or vRealize Network Insight, which is a necessary component within the solution, and you'll see why. So I just want to give a perspective of where Todd and I have been, and where we're coming from an application perspective. First of all, the majority of the VMs out there for applications are 1 or 2 vCPUs, 8 gigs of RAM. Databases are slightly larger, 4 to 8 vCPUs, 32 gigs of RAM, and typically deployed over 80% on 2 processor servers. So both Todd and I have been involved in the virtualization of monster VMs of sizes of 1 terabyte to 4 terabyte, and we've written or co-authored most of the performance papers around best practices of deploying databases. So, and there's about a 90-10 rule. 90% of the optimizations, 90% of the best practices are common across all databases, where 10% is unique and or questionable from an operational perspective when you're talking about best practices. So those heuristics, those best practices, they're well known. There's nothing new happening there from our perspective. So we're moving on to day 2 operations. We've told you over the years how to virtualize. It's not a mystery how to virtualize your database. Now we want to tell you why. And that's what we're going to focus on here. So again, as an architect, I look at NSX, a lot of great features, workload isolation, micro-segmentation, security. But as an architect, I expect that from a network. I expect it to be highly available. I expect it to be secure. And I expect it to be safe. So that doesn't really move me from an architectural perspective. So why should application owners, DBAs, CIOs care about NSX? And that's the perspective we want to bring to NSX. So what we did is we looked at how NSX operates as far as the elimination of network hairpinning, and there were some startling results. Better performance. And that seems a little counterintuitive in our space because we're typically talking about the penalty associated with virtualization, somewhere in the 7 to 10% range. So if we found a product within our stack that actually accelerates performance, then that becomes very interesting to application owners. And what we're seeing is, conservatively, 40 to 60% acceleration within the application. That's end-to-end. And depending on the operation, we're seeing the application run 2 to 3 times faster. So this reduces the time to value for the business. You're bringing actionable data to the business quicker. That gets their attention. And this elevates the discussion because Typically, you don't see networking engineers sitting at the table when you're making decisions on your ERP system or CRM system. So this will bring those people to the table, because trust me, if you can tell an application owner that you can make their application run 40 to 60% faster, you're going to get their attention. So this is not an NSX session, but I do want to provide just a quick overview of NSX. NSX gives you the ability to abstract layer 2 through layer 7 network services. You can think of it as sort of a network hypervisor. So as you would abstract a server resources, CPU, memory, or storage resources for your virtual machine, you can now do the same with NSX in software. So starting at the bottom, the data plane, when you install NSX, you're going to be installing these VIBs, VMware installation bundles, and these are installed in the kernel space, as everybody knows. So these networking services will be executed in the kernel space, and that's key to the solution that we're going to be describing. That's key to the performance gains you're going to get as well. Going up to the control plane, the NSX controller is responsible for the routing and the switching modules, and then in the management plane, this is the UI, where you can generate these services, and it looks just like vSphere. So if you are in the networking space, you're probably familiar with this slide, and what we're depicting here is really four different scenarios, and these 4 different scenarios are what we're going to be talking about throughout the session, and these are the measurements that we've taken. So before NSX and with NSX. And before NSX is virtual distributed switches. So the comparisons we're doing is how does the traffic flow with a virtual distributed switch and then with NSX. So for instance, you can see here that before NSX, the network traffic has to be routed externally and then back to the virtual network, and that is the definition of network hairpinning. So it's a performance penalty associated with unnecessary traffic flow from the virtual network up to the physical network and then back down to the virtual network. So you can see here with NSX only that if the VMs are on the same host, communications never go out to the physical network. So your communication is at memory speeds. So you can imagine what that does to latency. And what we wanted to do in our experiments was deploy real-world applications and then measure what the effect of the elimination of hairpinning was to these real-world applications. So if we back up to pre-NSX and we look at virtual distributed switches and how the traffic flows, this is what we're depicting on this slide. And there is a general confusion on how traffic is and is not routed using virtual distributed switches. And for the most part, if you start on the far right-hand side, whether it's on the same VLAN, different VLAN, same host, different hosts, network traffic is always going to be routed externally. It's always going to be routed through the physical NIC. The only use case in which it isn't routed out through the physical NIC is when it's the same virtual switch, whether that be a standard or distributed switch, and it's on the same VLAN. Now that use case isn't an enterprise use case. So you're not going to be deploying an application on the same VLAN. So wherever you have a mission critical or business critical application, you're going to have multiple VLANs. So basically, with a virtual distributed switch, your traffic will be routed externally, and that's by definition hairpinning, and that's what we want to eliminate with NSX. So let's kind of compare the traffic flow here with NSX. So NSX leverages the Virtual Extensible LAN or VXLAN technology, which essentially is an overlay technology that isolates the original Ethernet packet that's generated by either the physical or the virtual workload, and then it pads it with additional information. This overlay technology is pretty much a de facto standard. In fact, VMware was one of the co-developers of this VXLAN overlay technology. So here, I'm just going to concentrate on a couple of foundational components within NSX, and which are kind of relevant to our discussion. So with NSX, you can deploy these logical switches. And these logical switches allow you to kind of isolate layer 2 traffic based on to a particular, and you map it to a particular workload. So for instance, here you have, we created 3 logical switches in this example. One is mapped to the web tier, one is mapped to the DB tier, and one is mapped to the application tier. And these logical switches appear as port groups on your virtual distributed switch. So it's a familiar construct, the difference being that the port group is backed by VXLAN technology. And as you can see, these 3 logical switches are connected to a distributed logical router or DLR, another construct within NSX that operates within the kernel. So what the DLR allows is these different subnets, VMs on these different subnets, to communicate with each other without going out to the physical LAN and physical network. So our goal, or what the takeaway of this session should be, is that we want to kind of isolate that network traffic to a single ESXi host and look at logically related VMs. And what I mean by logically related VMs are VMs that constitute an application stack or a business workflow. So in this very simple example, if the web tier, the VMs associated with the web tier were communicating with VMs on the app tier, which are communicating with VMs on the DB tier, and they were on the same physical host, the communications would never leave that host. So you're communicating at memory speeds, so latency is near 0. So the components of this solution, or the components which make this possible, is first of all is NSX. So NSX is the enabling technology. It eliminates network hairpinning. Next, as I said, our design goals are to co-locate virtual machines that are logically related, that you're going to do via live migration or vMotion. And then to determine which VMs should be co-located and when they should be co-located, we're going to be using vRealize Network Insight to provide that intelligence as to when, which, and where those VMs should be located. And these optimizations are not possible in the physical world. You can't move servers, you can't move your application from one physical server to another, only through the power of the SDDC. So some of the typical day 2 operations that can benefit from NSX are essentially any data movement within your enterprise. So the use case that we tested was the enterprise data warehouse use case, where you're doing multiple loads into a single EDW or database of record. And we'll be going over that in later slides. But think of backup and recovery, node reconfigurations, IoT, again, any kind of data movement in your enterprise, and any type of applications which are latency sensitive, like databases or telco type operations. So with that, I'm going to turn it over to Todd.
Okay, thanks, Bob. Excuse me. So at this point, you guys are in the same position I was like 8 months ago, where Bob talked to me a lot about this, and I was like, okay, that's all really cool, and theoretically there should be some performance advantage, but I was like, it couldn't be like that big of an advantage. Right? I mean, you're just making the network path shorter, reducing some latency, right? But we decided that we would test it and get some quantifiable data so we could figure out exactly how much the performance could be improved. Now, the use case that we decided to use, like Bob said, is like a database warehouse where we're loading it. So in this case, the first case I'm going to talk about, it's an Oracle 12c database on Linux. We're using tables from a DVD store workload. So this is, they're different tables, so they've got slightly different characteristics in terms of the types of columns that are in them. The number of rows in each of the tables is a little bit different. So it's not just a homogeneous set of data, it's a little bit varied. For the setup, we went ahead and used an all-flash array so that the storage wouldn't be a hindrance to the performance. It's fiber channel, or it's? Fiber channel. Yeah, fiber channel, right, yeah. Thank you. Storage wasn't a hindrance, it's fiber channel. And then the other thing I want to talk about on this slide is these four scenarios. So there's four different scenarios that we're going to talk about, that I'm going to talk about a bit, and it can be a little confusing. So I'm going to try to step through it carefully because there's a bunch of numbers and scenarios, and I don't want to lose you guys through miscommunication. So just bear with me. So basically, you see on the first side we've got kind of the best case scenario for us being able to reduce the time or improve the performance, where we've got both VMs on the same host. And the first one is with the virtual distributed switch, where we've got to go all the way back out and down. So this is the hairpin. And then the other case is where they're on the same host. We're using NSX, and it just stays on the host. So it's a very short path. So those are the first two scenarios. The second two scenarios are with the VMs on different hosts. So this is still a chance for us to optimize the path. It's still shorter. It doesn't have to go all the way back to the physical router, but it is going to go out of one host and into another, right? Whereas on the with NSX, but with the virtual distributed switch, we're still going back out. So those are the four scenarios. We've got same host, different host, virtual distributed switch, and NSX, and we mix them all together. Okay? All right. So these are the results. So I'm going to talk about it for a minute, and you can kind of start to absorb the numbers as I do. So on the same host, as we expected, we're getting a bigger performance gain than we do when they're on different hosts. So with the NSX, so this is time in minutes and seconds that it took for us to load each of these different tables. This is just a sampling of the tables that we loaded, and we actually did a full load, which is a bunch of files. I don't remember how many, like 20 or so. But this is just some highlights. So we've got the reviews table first. It's got 30 million rows. It's about 14 gigabytes worth of data. And with NSX, it only took 2 minutes and 50 seconds. But with the virtual distributed switch, that same data took 7 minutes and 33 seconds to load. Right? Just because of the shorter path, reduced latency, and the speed that you're able to get everything across without having to go into the physical network world. As you can see on different hosts, we're still getting a performance advantage with NSX, a pretty big reduction, but it's not 2.5x, right? It's a smaller advantage. But in all cases, like you can see here, NSX is faster or better performing than the virtual distributed switch solution was. And then the bottom line is like this is for the full data load. So all of the tables, the time that it took cumulative to load all of them, you can see that it's about two times faster with NSX.
And I would just add that, we did this on a small to medium-sized database, 150 gig database, but EDWs are significantly larger than that. And their batch loads are going to take anywhere from 8 to 12 hours. If you can cut that time in half, that's game changing. That's something that application owners are going to take notice of. So from 8 hours to 4 hours or 12 hours to 6 hours, you're turning that instance over to the business much sooner.
Yeah, definitely. And then this is another chart showing the same data, but this is just all in percentage terms. So this is the percent that NSX was better than the virtual distributed switch with the different tables that we loaded. So the blue bars are on the same host. You can see them about 60% for the first three, and then a much faster, 100% faster in the last example. And then the green bars are for the same, for when they're on different hosts. So like I've said, I mean, it's still a significant improvement in performance, but not quite as big as when they're on the same host. Okay, so these numbers are awesome. Like, it's really cool. It's way bigger than what I thought they were going to be before we started. So we should slow down for just a second. So this is a really good use case. This is an example where it's going to work really well to NSX's advantage. And one of the reasons is that in this case, Oracle specifically has a really great data import capability. It can really bulk load data fast. You can disable logging, which is what we did. You can flow the data in really, really fast. So as fast as you can get it across the network, it will go into the database. So the network really is a huge component of the performance in this scenario. So because of that, we see a really big impact. In other databases even, right, it's not going to be the same. And I'm going to talk about some results on the next slide that specifically call this out. But we tried to categorize, some example databases in this I call this the funnel slide. Whereas the ones at the top, you're able to really optimize how fast the data can go in due to either the simplicity of the database tables, like the miasm tables on MySQL, or with Oracle being able to completely disable logging for bulk loads. And then as we go down, it's, performance isn't going to be as big of a gain because there are other factors that are going to be slowing you down. The database may require logging to occur. It won't let you turn it off completely, which is a good thing, right, depending on what you're doing. So it's just important to realize that there's a bunch of things that are going to affect how much this performance advantage that we're offering by eliminating hairpinning is going to really translate into the workloads that you're using. So it potentially is really, really big, right, like we've been talking about, but in some cases it's going to be a little bit less.
But the other thing is, if you've heard Todd and I talk before at VMworld, which we do probably almost every VMworld, we're usually talking about database overhead and trying to explain away 7 to 10% worth of overhead. Here, Todd's talking about small performance gains in the 15 to 25% region. So the overhead becomes, it's a non-issue anymore. This is like a completely different world for us when we talk about performance. Usually we're talking about, like you said, like how do we mitigate the performance overhead from virtualization, make sure that it's as small as possible. And now we're talking about a situation where we're virtualizing the network and it allows us to potentially get some really big performance gains. So it's a lot more fun on this side, I think, okay. Okay, so the other test or set of tests that I did to illustrate kind of what I just talked about on the other slide is with the MySQL database. So MySQL has what they call a pluggable engine architecture. So it supports different table types, or they call them storage engine types. And each one of those has its own characteristics. Now the two most common ones or most popular ones are the NODB and the miasm tables. I think I'm saying miasm right, but I really don't know for sure. So anyway. NODB is full transactional support. So it has logging that goes on all the time. You can't disable it. That's how it guarantees that it can roll back transactions in the event of something happening in mid-flight. So it's more robust in that nature, but the logging does slow things down when you want to bulk load a bunch of data in, right? Miasm is a more lightweight table. You can turn off the logging entirely when you're doing bulk loading, which is what we did here. So in terms of being able to load a bunch of data in quickly, it's a higher performance table than the NODB. So the really cool thing about this, right, is that this is MySQL, and all we changed, I literally just had to change like 1 or 2 lines in the database creation, and everything else was the same. So I'm loading the exact same data on the same VM across the same network. Everything's the same except for these storage engines that we're changing. So this allows us to kind of
figure out how much of an impact this allows us to illustrate how much of an impact just the kind of the different type of workload or the database that you're using can have on the performance. Okay. Okay, so in this slide, these are the results. Same 4 scenarios that we've been talking about. The bars on the right, the big bars, this is all elapsed time, so bigger is bad. It took longer. The bars on the far side are for the NODB tables. In the 4 scenarios there, you can see that the blue bars, which are the same host, are a little bit shorter than the green bars, which is where the VMs are on different hosts. So we are getting a performance advantage with NSX in that shorter path. But that's not the deciding factor in where the time really is. Or it's really dictated more by how long it takes for everything to get logged into the database and entered. That's taking much more of the time than the network is, right? So the network's not nearly as big of a factor in this, but it's a little bit of a factor. About 10% in both cases, when they're on the same host and when they're on different hosts. But with the miasm tables, our times are much faster in both cases. We're not hung up on the database. And we see a much bigger advantage for NSX in this case. So it's about 35% better on when they're on 2 hosts, and when on the same host, it's about 60-something%. So it's very similar to what we saw with the Oracle test results. And then this is one more look at the data. These are the same test scenarios, but this is the average network throughput during the data load. So you can see that with the NODB tables on the right, it got up to about 200 megabits per second in all cases. There's a little bit of difference, right, which is showing up at about 10%, which reflects what we saw in the overall time. But with the miasm tables, with us being able to really load the data in quickly, we're able to get a lot more network bandwidth going. The network's a bigger part of the equation of the performance, and hence we're able to take advantage of eliminating the hairpinning to a much bigger degree. Okay? So I thought these numbers were really cool. Hopefully it comes across. What, Reza? The Y, no, it's not correct. Thank you. It should be megabits per second. Thank you. Good catch. Okay, back to Bob.
And just one other thing I want to point out about the measurements that Todd and I took is that we didn't try to influence the database at all. This was a vanilla installation, and certainly there was opportunities to optimize these numbers or to drive these numbers even to look even better, but we didn't want to take that route. So this is a slide I borrowed from my last year's presentation, and I really want to make the point here. 2 points is that, first of all, this is from my SAP HANA session, where you can see it's a very complex network, so it really lends itself to virtualization. But what I really want to point out here is that I've taken some excerpts from the HANA design spec, and I want to really drive home that latency is a real issue within distributed systems, and especially distributed databases. What the guidance that they give you is the distance between nodes should be as short as possible. So these are servers. They want to have those servers as close as possible in the same rack because it will impact performance. Remote loads, which we just showed, or distributed queries, which we didn't show, but we did the remote load as our use case. So going back, you can see that VMware does one better, right? We're not tied to any physical servers. We can migrate those virtual machines so they're co-located on the same server, so latency essentially is near zero, and we're operating at memory speeds. So again, this is not possible in the physical world. These optimizations can only be done in a software-defined data center. Now, secondly, how do you execute on those design guidelines that SAP put forth, or many of the database ISVs when you're talking about large distributed systems. You've deployed a HANA database, maybe it's 4 nodes, and now you've got to grow it to 6 nodes. Those 4 nodes could be residing on a rack that's in a different row than where there's servers available. So what do you have to do? You have to arrange to move those servers. You got to talk to the application owners. You got to potentially recable them. So to execute on the design guidelines, it's very disruptive. There's downtime, and you have to communicate with application owners. Not the case with VMware, right? You can just vMotion those applications off those servers and expand your database by vMotioning those new nodes or deploying those new nodes directly on that physical host. So no downtime, no recabling. Again, the power of the software-defined data center. Now, we touched on NSX, but NSX is much more. But we're keying on the performance around the elimination of network hairpinning. There's a lot going on with NSX, load balancing, QoS, security, firewalling, all beyond the scope of this session. But I do want to talk. I want to briefly talk about security. So with databases, encryption of databases can be quite expensive, depending on the particular ISV. It could range from anywhere from 3 to 30%, and again, that's depending on how CPU intensive and how IO intensive it is. So database guys are reluctant to encrypt because of this performance penalty. So this is another use case where you can apply security rules to the database. It's not full encryption. It's certainly a lot lower level of security that you would have if you encrypted it, but there's no performance penalty associated with it. And these rules can be applied as at a database level or a cluster level, and that's what we're going to show in the next slide. So we wanted to determine what the performance overhead of NSX when you would deploy these firewall rules, and obviously you can create thousands of rules. You can scale out performance of 20 gigabits per second, but we wanted to create a set of realistic rules within our test bed. And what we did was create these firewall rules, a set of 10 firewall rules to protect the database based on the virtual machine name, the type of OS, the port group, and the logical switch. So we firewalled off, we secured the database and the application tier using these rules, and instead of putting a graph up there which was flatlined and show no performance degradation, there was no performance degradation. Again, this wasn't a boundary test. We weren't trying to test the limitations of NSX. We were trying to create a realistic set of firewall rules to protect those databases. So we talked about vMotion, we talked about NSX. The third component of this solution is VRNI, or Visualized Network Insight. Distributed Resource Scheduler is a great tool. It balances the workload across any given cluster, but that's not what we're after here. We're after latency. So for instance, a VM could be, if you put DRS in automated mode, it could balance that cluster, and you could have your nodes on opposite ends of that cluster. And again, that's not what we want. We want to exploit a locality. We want to exploit the reduction of latency and keep that workload as close as possible. So for our purposes, DRS is not sufficient. However, with predictive DRS and then creating some DRS rules, we can make it function better or in the manner that we want. So that's why we couldn't wholly use DRS, but we were relying on Network Insight. And what we were able to do with Network Insight, VRNI, is kind of model that database behavior and understand when and which VMs were communicating with each other. Because as in our simple explanation where we said you can co-locate the application, database, and web tiers on the same physical host, that's not realistic. You can't locate the whole application, but you can co-locate the components of that application stack based on when they are communicating, and then vMotion them off. So that's the kind of intelligence that we needed to make this solution work. And we also wanted to be able to predict the degree of application acceleration with NSX when you eliminate hairpinning. And don't let the name fool you. vRealize Network Insight doesn't only collect network stats. It captures the vCenter stats, NSX controllers, obviously, converged infrastructures, and physical switches. So you can make those complex correlations throughout the entire stack. You're not looking at just the network statistics within VRNI. So here we tried to determine that degree of performance, as I mentioned in a couple of slides previously. So what VRNI is, it exposes that topology, topology so you know how many devices your communication is traversing, and then from that you can also measure or determine the number of packets. So latency is basically how many network devices is your communication traversing, as well as how many packets are being pushed through those devices. So with that, you can make some approximations as to your degree of performance acceleration when deploying NSX. This is another useful view. It's kind of the top N talkers or top 10 talkers here, because once you deploy an application, your application architect kind of knows which sources are communicating with each other, or which sources are source destination things. But as that application grows, there are additional sources that are added that the application owner may not know about. So that was what we wanted to do. We wanted to map the application's temporal characteristics and determine which, when, and where these VMs were communicating. And think about that massively parallel database architecture or distributed systems where you can determine which node or nodes are participating in a particular query or generating a particular report, and then co-locate those VMs. So again, exploiting that temporal nature of that communications. And also you can determine if the data is properly partitioned. It could be sharded, it could be hashed, or just partitioned by usage. And from the network stats, you can kind of see, well, is this the optimal distribution, or should I change my distribution strategy? So the bottom line is that NSX provides that technology to eliminate hairpinning, and then VRNI provides that knowledge to understand and optimize your stack. And as I mentioned previously, to make those complex correlations, VRNI captures data, has many data sources. So you can almost think as VRNI as a data mining type of operation where you're getting data from multiple sources and then looking for those correlations to optimize your infrastructure. So this slide here is probably one of the most important slides, and it may be a preview to next year's session. But if you're a networking guy, and the results that Todd presented earlier were a little questionable to you, virtual distributed switch on the same host versus virtual distributed switch on different hosts, you would think they should be similar, right? Because it's the same number of hops. You're still going out to the physical network. So why aren't these the same? And that's because we're not looking at the network. We're looking at the performance of the application. There are other factors that come into play and other benefits of co-locating those applications. And they can manifest themselves in the form of NUMA, L1 cache, the efficiency of our scheduler, et cetera. So this is where VRNI becomes very powerful because it can determine those other benefits, those other complex correlations. And this is an extremely important concept within the SDDC. So I'm going to turn it over to Todd for conclusions.
Okay, so just to kind of wrap up what we talk about, by putting NSX into this environment, you have the opportunity to do a few things, right? We've got kind of three main points. The first is that it immediately provides some value, right? You can get this immediate performance benefit with these use cases that we've talked about. But in order to evaluate where that's going to come from, right, you can use VRNI to evaluate your existing infrastructure, spot areas where it's going to potentially impact things ahead of time. So yes, you can talk to application owners, and that would give you an idea, but a tool like this can go in and out on your actual network and see what's really going on and give you some concrete numbers to start with. The other thing is that we kind of talked about this earlier. The virtualization of a database becomes not the big issue anymore. The potential gains that we can get for virtualization with the virtualized network with NSX are much bigger than any overheads that are typically associated with virtualizing the database. And you're going to cover the last one, right?
Yeah.
Okay.
Yeah, I think about differentiating your business outcomes through day two operations, and think about a use case where you're doing a month-end close, and a month-end close involves many data sources to come up with your ultimate revenue numbers that you're going to publish to your shareholders and to the public. If you can reduce that cycle by many hours, 8, 10, 12 hours, then you're leaving your books open for that quarter a longer period of time, which means you could report more revenue. So this type of a solution and what you can do in the software-defined data center has impact to your business. And that's just one business cycle that I'm using as an example.
I think that's it. So there was a couple of kind of follow-up things. Oh, so there's another session that Bob is involved with.
Yeah.
You should just talk about it instead of me trying to explain it.
Yep. So our executives kind of looked at these results and they thought that they were great. That me and Todd published the results, the blog, they thought it was great. However, they said, you need to have these validated. These are too good. Let's have an external validation. So my new buddy over there, Hanan from Deloitte, contacted me out of the blog, and he wanted to know more about my results and our results and how we came about this. And our executives kind of said, well, get it validated by either an SISO or a partner. Well, Deloitte is an SISO and a partner. So they decided to go off and do their own POC, and I'm not going to steal their thunder. We're presenting on Thursday, but their results were very much in line with ours, maybe, and even a little bit more impressive. So if you're around Thursday at 1:30, I don't know how we pulled these terrible slots for our sessions, but we did, so if you're around, that's what we'll be presenting with Hanan and Ryan.
There are a couple of hands-on labs that are also oriented around performance, to check those out. And then this is a performance survey. So there's a survey for this session, which we'd also like you to fill out. But this is a different survey. This is for the performance team specifically. It's got a lot of questions that we would like to get direct feedback from you guys. If you'd like to be able to give us your opinions about what you feel about how our performance is, how we stack up against our competitors, things that you'd like to see more of or less of that we do, please fill out this survey. It'd be great. And with that, we are done. We're happy to take questions.
We thank you for foregoing the beer and the hall crawl to come to this session. So, any questions? Yes, we do. It's in the back here.
So, on a scale-up database, it has to be physical, right? Is there any performance gains to be had with NSX and the VTech connection to a physical switch?
Why do you say scale-up database has to be physical?
Well, I mean, the most that I know you can run on virtualizers is 4 terabytes, right? So
Right.
the 16 and 24s and stuff like that,
Okay.
SAP databases, you can't virtualize that, right?
Yeah,
So is there any NSX performance gains to be had with using that on a physical switch?
performance gains on a physical switch or an NSX type? Okay, so
Is there any application
there,
that is even possible, I guess, using a scale-up database?
yeah, absolutely. So what I think what we have to train ourselves to do is think end to end, right? That there's latency throughout the application, not the database. So in your case, where if you are deploying a SAP HANA database that exceeds our 4 terabytes limit, then you'd have to leave that physical. But then that end to end or the user experience traverses many tiers. So you can reduce the latency throughout those tiers and still have it connected to the physical database. But you're talking to, I guess, the guys that are, well, I'll let you speak around limitations around HANA. But again, those are corner cases, but understood. But there are certainly opportunities to optimize that stack because yeah, perfect. Because once you've collected the results from SAP HANA or any database that exceeds our limitations, you then have to present it somehow. And how does that presentation get to the end user? Could be through an EDW or whatever. So that application tier can be optimized through reducing the latency with NSX.
It's interesting that you're here. So Bob and I did a lot of SAP HANA stuff. I'm still involved, but we usually end up finding that even the large databases end up being under 4 terabytes. Not always, but so yeah, I'd be interested to talk to you just to find out about what your scenario is, just out of curiosity. Anybody else? Okay, go.
Well, with the current AWS, we actually do control the physical layer, so that you essentially think of it as a VMware stack that is managed and located at AWS. So you can absolutely take advantage of all of our VMware vSphere capabilities within that stack, subject to supporting of those different components. Like I know VRNI is not supported, this release is not supported within AWS, but as you make those decisions, then you can determine if that fits your development window or production windows. But it is a vSphere stack that resides at AWS. Yeah, so as you would expect, I mean, and Todd alluded to this as well, is in transactional workloads where, it's very bursty, 250 milliseconds or whatever, the number of packets that are transferred, it's not that great, in comparison to when we're doing data loads where we're moving millions of packets. So the latency is additive. So the more packets that you're processing, the greater degree of performance acceleration you're going to get, as opposed to just bursty transactional workloads. We do want to test this of all things with SAP HANA, because that does generate a lot of network traffic, even though it is even within a transactional workload. So as we were saying, with VRNI, you can determine, approximate that performance gain based on how many devices you're traversing and how many packets are traversing those devices.
So our plan is to try to characterize more workloads, quote unquote, after VMworld. So there's this big push, right, to get everything, and we're going through that now. But yeah, this fall, we're going to work on some more characterization.
Yeah, I think we're going to try to work on SAP, the SGen workload, which you should see some significant performance gains there, which would address your questions. Any other questions?
All right, well, I think we're done.
Yeah, again, thank you.
Thanks everybody for coming.